Okay, I'm looking at a packet that says commutative and associative properties of addition. Okay, so each one of these is an example, and then you have to decide which property of addition it is. Now, there is one thing that I want to warn you about, and I'm just going to do an example up here at the top. You don't actually have to copy it down, but you are going to want to listen. Okay? Most of the time when we see parentheses, it's going to give us a hint. What might the property be if I see parentheses? Which property talks about using parentheses? Commutative or associative? Stella. The associative property talks about using parentheses, right? Okay, so most of the time when we see parentheses, it's the associative property. But sometimes, in true math trickster fashion, the person who wrote the assignment or the quiz or the test is trying to trick you and seeing if you're really paying attention. For example, if I have 7 plus 4 plus 5 in parentheses, and I say that it is equal to 4 plus 7 plus 5, which property is that? Is that the associative property or is it the commutative property that I'm using? Lots of hands should be up. You have a 50% chance of getting it right. You're going to say associative or commutative. There's only two options. Your odds are good. What do you think it is, Levi? It's not. You just got tricked. Because, look here on this side. What are the numbers in the parentheses?
7 plus 4.
What are the numbers in these parentheses?
4 plus 7.
Are they the same numbers?
Yes.
Yes. So we did not group the numbers differently. We still grouped the same two numbers together. What we did was we switched the order. So just because it's parentheses, you can't look at it and automatically assume that it's going to be the associative property of addition. Okay, it could be commutative. It depends. If I had said this, then now I have different numbers in my parentheses. That's the associative property. Does that make sense? Okay, so let's look down here at this example. Can you work out 48 plus 21 plus 79 without using a calculator? Here's an easy way to work it out using one of the laws of algebra. 48 plus 21 plus 79 is the same as 48 plus 21 plus 79. Why would we group together 21 and 79? Why would I group those two together? Cordelia?
Because it makes 100.
That's exactly right. Because 21 plus 79 adds up to 100. And 100 is easy to add to 48, right?
Yeah.
Miss Canterbury, if you could check in on him, I'm not sure he's with me. That is equal to 148. So which property did we use to make this adding easier? Did we use the commutative? Did we change the order of the add-ins? Or did we use the associative and change the grouping of the add-ins? Or did we use Mrs. Young's classroom laws or Mrs. Amsbaugh's speeding laws? Which one did we use here? Caden, R.
I think that we did the commutative.
Okay, so commutative says we're switching the order. So if you remember, commutative means we're just saying instead of 7 plus 3, we're doing 3 plus 7. If I look here, the order is 48, 21, 79. Here the order is still 48 plus 21 plus 79. So we didn't switch the order. What did we switch? What did we switch? Addie? We did the associative property. We grouped together, instead of grouping together 48 and 21, we grouped together 21 and 79. So now in my head, I can think, well, 20 plus 70 is 90. 9 plus 1 is 10. That gives me 100. As opposed to 48 plus 21 giving me 40 plus 20 is 60. 8 and 1 is 9. 69 plus 79. That's hard to add. But 48 plus 100 is not hard to add. Okay? Okay, you should be looking at the screen. Okay, can you work out 73 plus 89 plus 27 without using a calculator? Here's an easy way to work it out using one of the laws of algebra. 73 plus 89 plus 27 equals 73 plus 27 plus 89. Did I switch the order or did I switch the group? Are these in the same order as they are here? No, so I switched the order. What property switches the order of the addends? MJ, what property switches the order of the addends? Not identity. Which one is it? Avery? Commutative. It's the commutative. Oh, wait, hold on. Yeah, the commutative property. It's not Mrs. Campbell's positive attitude law, but I do like that positive attitude. Then in the second step, we grouped the numbers together, but even though we grouped them, originally they were not grouped. So that's why it's not associative property. We switched the order. Right, everybody make a note. Switched order. If you switch the order, it's commutative. Even if you add parentheses. If you switch the order, it's commutative. Even if you add parentheses. Okay? And Miss Campbell's positive attitude law, I like that one because it means to keep thinking, I can do it, I can do it. Okay, turn the page. Victor DeVelo was the lead rider for Team La Française des Jeux in the 85th Tour de France, a bicycle race which takes place over 3 weeks and winds through the French countryside, past the coast and over towering alpine mountains. To keep track of how far he has gone on 2 consecutive days, Victor can add the 2 distances in any order and the total remains the same. This is called the commutative property of addition. Everyone underline, add the 2 distances in any order and the total remains the same. That's what we're focusing on. For example, if the prologue of the tour is about 6 kilometers and stage 1 is about 181 kilometers, Victor can add the distances in either order to get the total for the 2 days. So Victor can do 6 plus 181, or he can do 181 plus 6. Either way, he's going to get the same sum. Raise your hand if you know the sum of the 2 days. 181 plus 6. What is the sum? Owen?
187.
187. If you're just coming in, this is recorded in Canvas, and you should have time to listen to it today during RTI. Okay. To find the total for the first 3 days of the tour, Victor would add 6 kilometers plus 181 kilometers plus 206 kilometers. And that word add is a math action word. We could do these addition problems from left to right. However, since they are all addition problems, we can do them in any order and still get the same sum. So instead of just reversing the order this time, we grouped together using parentheses. Give yourself an asterisk. Grouped together using parentheses. Okay? So, we have 6 plus 181 plus 206. In the first problem, thank you, ma'am, we have 6 plus 181 plus 206. In the second problem, we're going to do 181 plus 206 first, and then add 6. Okay, so what I want us to do is this. Let's go through this algebraically, and everyone just rewrite it neatly down here on the bottom. Okay, we already know what 6 plus 181 is. What is it? 187 plus 206. Okay, what is 181 plus 206? Who can tell me? Let's do it. Let's just break it apart. What's 100 plus 200?
300.
300. 80 plus 0.
80.
So it's 380. 1 plus 6.
70.
1 plus 6. 387. So now we have 187 plus 206 is equal to 6 plus 387. Let's see if we're right. 100 plus 200 is 300. 80 plus 0 is,
80.
so 380. 7 plus 6 is,
13.
so 380 plus 13 is 393. Now we have 387 plus 6. What is that?
393.
Okay, let's raise our hand. What's 387 plus 6? Everyone should either have their hand up or counting it off on their fingers or writing it down up and down to figure it out. What's 387 plus 6? Gracie?
396.
No. 390? 393. 7 plus 6 is 13. I can add 13 to 380. That's 393. Okay? Now, I was just doing those in my head and using an example of breaking it apart. But let's just come over here and add those vertically. What do we call this when we add numbers up and down? Starting on the right, we call it the what? That was in our standard we read yesterday. Standard. What's that big word? Algorithm. Everybody say it with me. Standard algorithm. Say it again. Standard algorithm. Okay, now I say standard, you say algorithm. Standard? Algorithm. Standard? Algorithm. Okay, so everyone, let's walk through that just one time. So the standard algorithm says we write the numbers vertically up and down and line them up by place value. So my ones digits are lined up, my tens digits are lined up, and my hundreds digits are lined up. Then it says I start in the ones column or the farthest place value column to the right. 7 plus 6 is 13. The standard algorithm says I put down the digit in the ones place and carry the tens digit to the tens column. Now I need to add 0 plus 8 and add in that 1, giving me 9, and 2 plus 1, giving me 3. This is our state standard using the standard algorithm. That is what we need to be able to do. Okay? There's one more. Everybody turn to the back. The commutative property, or changing the order of the numbers, is important because they allow us to change the numbers only in addition. It doesn't work in subtraction. The associative property, or grouping numbers in different ways, is important because they allow us to easily group numbers in different ways only in addition. It doesn't work in. Okay, here's a page from Victor's Racing Journal. Tell which property he used to calculate the distances he rode. Okay, so stage 3, stage 4, stage 5, stage 6. So the total for stages 3 and 4, total for stages 3, 4, and 5, total for stages 4, 5, and 6. I want you to work with the person sitting next to you to complete these 3. You need to come up with the sum, and you need to state if it's the commutative property or the associative property. You can look in your math journal on page 34, or you can look up here at these clues.